Okay, I tried to do this earlier, did not work out. So here's the two things you need to know. The first thing I need to tell you is people I need to give credit to. So this book is this guy's life's work. So give credit to this man over here. The other person you should give credit to is this person over here. The C2, C3, all the way to Cn. This is called the column vector. We see a row vector here. We see an inner product, and I guess in this book, inner product is u comma v this, which equals u I v I. Okay, and summation of all those. Isn't that just a dot product? Yes, it's a scalar product, so it's a dot product. So we're going to represent it as this because this is an easier index notation. Doing a summation with a ui and vi is correct, but that does make you do more work. This part over here is more work. The norm, right? We take the norm of this, ui vi, and that equals to square root of u1 squared plus u2 squared plus so on to un. Okay, let's square it. Here's my take on this. That's great. So I guess none of the other norms are important, only norm 2. So norm 2 is king. We don't care about the other ones. That's what appendix 1 is telling me. Norm 2, forget the other ones. For now, the vectors u1, u2, and the u3, un are said to be linear independent when there is, so this is basic algebra, where there is u1 plus a2, u2, and plus dot 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 a and un equals 0. What it's saying is that to be linear independent, this must be true, where ai over here equals 0. And then that makes it linear independent. Otherwise, this doesn't stay true, and so on and so forth. And then that is all it's saying. I want to, and then, yeah. I'm slightly perplexed on this, but we'll see what's happening. So we always look at the inner first, right? So over here, we have x here. What that x is in the input. So if we were to say this, let's just look at the inside first. I equals 0, I does not equal j. And then n, which is 11, we figured out what 11 is. Okay, what n is. No, cancel, don't delete everything. So we can write n equals 11. And I hope it's following my cursor. 0.8 is going to be a plus, if I'm correct. If I'm wrong, then I'm wrong, but pretty sure it is. And then it's going to be minus 1 plus 0.8. Yeah, am I correct about that? Yes. And that's going to be multiplied because it's a product. Minus 1 is going to be permanent because this is starting from minus 1, which I should now think about this. This is a wrong notation. So what I have to write here is j equal 1. J equal 1 equals minus 1, and xj equal negative 1. So that means negative 1 here, here, and so forth forever. Now there's 11 of them, so there should be 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8. And so the x, again, plus because it's a minus 0. No, what did 0.8? 0.6. And then again, after 0. It's all even, so it's a plus 0.4, plus 0.2, and it's going to be negative 1 plus 0, and it's going to be negative 1 plus minus 0.2, and then so forth and so forth for the rest of it. Now, over here is going to be x plus 0.4, and so forth for the rest of it. And now we do this, and we multiply by this Hagrid number, 0.038. And there we have it, the polynomial, and there's a summation here. So therefore, you have to do that for I equal 2, 11. And then you are done. That wasn't really a proof, so I shouldn't do that. Happens here. So this looks like Gibbs phenomenon, actually, but I'm not sure if it's called that. But basically, if you think about it, if you have two dots, three dots close together, it'll most likely be like this, right? But yeah, in a polynomial sense, you have something like this connecting these three, and you have something like this. It most likely go like this, even though the real path might be like this. I don't know, well, maybe like this, or it might just be like this. We don't know, but you can kind of see the polynomial situation we have. It might not be the most accurate in this point over here,
All right, so here I want to show you a better way of doing Lagrange interpolation, which is by doing a non-uniform points. Because over here, as you can see, we're seeing a better indication over here than before, and we're gonna do it right now, and I'm gonna show it off. We get this, which is pretty good.